now we have the final discussion session. So let's begin. Any commentary, questions for John Nelson, John Knight? Nobody, nothing. I would love to hear from Herman again about this.
Actually, what I have to say was that coming to the United States in 1968, I had no problem correlating the major stages through the Mamurian and Westphalian up to the end of the Westphalian. Within the Stephanian, no. So in other words, the miscorrelation that both Wagner and Kliel have done in North America are totally unfounded, uncalled for.
I agree, yeah.
Well, the question, let me ask this question, because this is the core question. Does this Cantabrian stratotype, or whichever one it is, represent an interval of time that we can find elsewhere? Or is it just a chronostratigraphic construct based on what I might call a facies flora that exists in Spain? I mean, is there really an interval of time? I mean, because I'm puzzled, you know, Kliel reviewed the paper John Nelson and I wrote, and we wrote that paper last year. And by then, his paper with Besley must have been in press. And it seems the Besley paper removes it. There is no raison d'etre for a Cantabrian because there is no gap. Where is this interval? There's a magic interval of time, you're saying, John Knight, in Spain. Where is it elsewhere?
Well, I think you missed the point that I tried to stress, that the Westphalian D, or Asturian, has not been defined. There is no base to it, and there's no top to it. The Stephanian A has not been defined other than conceptually. There's no stratotype for it. Some people would like to take the base of the Holtz conglomerate. In fact, in its origin, it was the Stephanian A of the Rive de Gier succession in Saint-Étienne. That is a flora based on 100 meters of coal-bearing strata, the Peso de la Perronnière, and those workings have been closed since the beginning of the last century and are inaccessible. So nobody can get or understands what the Stephanian A in its original context in Rive de Gier stands for. There's good flora in museums, incidentally dominated by lots of lycopsids, you might like to note. And apart from that, there is a total lack of definition of any of the units across this period. In fact, a lengthy discussion is outside the Kasimovian, but how to distinguish between Westphalian C and Westphalian D, or Bolsovian and Asturian, if we wish, is still a discussion which should be held and has within it some extremely difficult decisions to be made about defining any difference in that interval. So I may not be answering your question directly, but only that the interval that was recognized by some people, I don't want to sort of get too heavy with the interpretation of German, but the interval that was recognized between the base of the Holtz conglomerate and is it the Heiligenwaldische? I can't quite remember. The top of the Westphalian, the as represented in the SAR, is represented in northern Spain. It's the time is represented by a continuous succession. In answer to your question, is it a specific facies? Well, yeah, come on, Spencer, you know, every rock succession is a specific facies. We've decided that marine successions are, in general, have the best correlation potential for global stratotypes. No problem with that. But in the context of Western Europe, you yourself in your paper put the material that says this is about the continental fasces of Western Europe. It's quite clear in that paper of Longmans and Pruvost. That's the context of the West European unit, substages. And, you know, it's not to say that elsewhere there aren't very good marine successions, but they're not correlating and, what shall we say, controlling the fasces represented by the Westphalian and Stephanian in North, Central, and Western Europe.
Okay, Ron Martino has a question. Ron, do you want to turn on your video and microphone, please?
Yeah, this goes back to, I think, Mitch Blake's paper from 2002. Just two observations. One, there has to be tonsteins in other basins that are in this gap of 308 to 304.9 that Wagner proposed. And in the 2002 paper by Blake and others, it made the case that this was actually more of a provincial flora that was time equivalent to those in North America. And nobody's really talked about that. I think Herman was involved in that paper. Would you address that, please?
Is for Herman to answer here?
Yeah. Ron, I did not get quite what you said. I was listening, but could you rephrase the question, please?
Yeah, in the paper by Blake and others, 2002, which I think you included in your presentation.
Yeah, I have it here. Yeah.
I think the point was made that the flora that Wagner considered unique didn't really represent a missing interval of time. It was actually a provincial flora that was time equivalent to those found in other basins.
That is part of it, but there are, of course, species that are common to the two areas. So it's not as if it's not correlatable, but the problem is that, for instance, Odontopterus cantabrica is a synonym of a species that has a much longer range. It's unusable for stratigraphy. So there were problems, and also the sequence of events that Wagner had described turned out to be completely different in the Appalachians.
Okay, well, let me get back to a point that Spencer was asking, and that is, you know, we're really trying to correlate or demonstrate that there's a missing time interval, and since the appearance and disappearance of plants can be diachronous, as with any taxon, we should really be trying to prove this with radiometrically datable horizons like tonsteins. And are there no other places in the world besides this Cantabrian mountains where we have tonsteins that are in that interval of time from 304.9 to 308 million years?
Yes, in France, in the Massif Central, they're probably about 20 or 30 tonsteins. Unfortunately, like everywhere else, and like the problems I've had collecting, originally when we had access to mines, we didn't understand about the potential for radiometric dating. So we collected hand specimens for petrographic study. And if any of those remain, you know, to use one's sacrificing it forever, as I did with the one from the tip of the Pfefferkorn beds in the Cantabrian. And they're very difficult to get back. You know, we know they're there. Getting at them is very difficult. But I would say that I do have slightly higher in the succession for the Siberian, as we're proposing it. You saw Stan using it in his section in the Severo coalfield fortunately, my collecting there was at a period when I was beginning to cotton on to the fact of radiometric dating. So if any of you want to spend your money on doing some radiometric dating, I have at least 10 horizons.
Okay. I want to end this discussion because I can see that John Knight is not going to agree with the weight of American opinion. But Jörg Schneider has one comment. Let me, Jörg, will you?
Yeah. If you look on the 21 publication of the Czech team, they have an increasingly number of radioisotopic ages. This is independent from biostratigraphy. This is another method. We could trust them or not. Anyway, when I look on this newest publication from Stan, then I realize he used Cantabrian, but he placed it in the lower part of the former Stephanian A. I think Stan, and Stan has also sampled an incredible amount of paleofloristic data. Possibly Stan should say something about this from his different two data sets, macrofloras and radioisotopic ages.
Did I read Stan's diagram wrong? Didn't he show dates that show the Cantabrian base at 305 or something like this in one place and 307 in another? Don't the dates show a diachronous base of the Cantabrica zone in Europe of about 2 million years? Wasn't that what I read from?
2.4 million years, I think, or something like that. Is the major difference, but between Czech basins and Spanish basins, the base of Cantabrian differs significantly, 1.7 million years, I think. Anyway, I use Cantabrian as identified by several taxa which appear for the first time, mainly Sphaenophilum oblongifolium and Odontopteris cantabrica, which is present in some basins, in some areas. And if this level is calibrated by radioisotopic ages, it gives simply this age. And it is a matter of discussion whether it is Cantabrian or something else and so on. So primarily, I was focused on calibrating the succession, and no matter whether we call this interval Cantabrian or, I don't know, Barruelian, Stephanian A or so. So my primary interest was to calibrate the succession and to describe the floral succession. Yes.
Okay, Bill DeMichael has a question. Bill?
I'd actually like to hear from some of the Continental guys to hear if they have discussions like this. If you have a series of fossils of any type that correlate to two different places in North America, to a different place in the Czech Republic, what use is that? I presume that if we had a global stratotype that we could agree to somewhere on Earth called the Kasimovian, we would all try to correlate our rocks into it. And if we had that be something like the Cantabrian and we couldn't correlate into it meaningfully, I would ask myself, I just use stratigraphy. So when I'm looking at a floral turnover, a climate change and its effect on, let's say, vegetation or on marine animals or whatever, I want to be sure that my timelines are reasonable. And if I have a thing where one base of it's here, one base of it's there, one base of it's there, I can't use it for anything. I mean, I can say I'm in the X-y, whatever you want to call it, but I don't really know that I'm in a time zone. So I'm not sure what to make of this whole argument. I'd like to hear from, I see Steve Roscoe is still here, Phil Heckel. I don't know if Jim Barrick is still here. Do these guys fight the same way like this? Do they have zones that are so offset in time around the world that they can't come to some agreement?
Sorry, Well, the point is that we're confusing chronostratigraphic stages with biozones. The biozones are definitely diachronous, and the plant biozones, I think I agree with Stan, can be very diachronous.
We're not, wait, John. But John, we're not confusing that. What you're trying to tell me, what Wagner tried to tell me in Cleel is, I use the first occurrence of Odontopterus cantabrica to define the base of a chronostratigraphic unit.
No, he
and
did
Stan
not.
just
Sorry,
showed us. Wait.
Stan
just showed us that zone base, whatever that first occurrence, is diachronous over 2 million years within Europe. It's useless even in a provincial chronology.
The Odontopterus cantabrica zone was defined far later than the Cantabrian. The Cantabrian was not defined on the basis of the floral zones.
Okay, well, listen. I want to try to redirect the discussion. I mean, we can argue about this forever. I want to go back to something that was very interesting in Sandra and Stan's talk. It struck me. This floral change that occurs across the Moscovian-Kasimovian boundary is obviously not synchronous across Pangaea. And what's happening way out in Western Pangaea is very different from what happens in the mid-continent to Europe. And so the question to me is, what's driving this? And of course, I thought initially it must be climate, maybe global climate. But Stan pointed out that some people think it's drainage, it's tectonism. And I'm wondering, how can we explain, or how can all of you explain to me why we get this floral change more or less synchronously from, say, Illinois or to Czech Republic, but in New Mexico, it's not happening. What is the driver of the so-called Carboniferous rainforest collapse? What's a driver that works only in that Euro-American region and doesn't apparently work for the rest of Pangaea? Somebody want to explain that to me, please? Is that a legitimate question? I mean, I'm coming from a position of fair ignorance, but I'm wondering about something that we thought, I want Jonathan Wilson to explain it to me, actually, that we've been calling global, but now we realize it's not global. Jonathan, explain this to me.
Yeah, thanks, Spencer. This has been a really wonderful day of talks and some really robust discussion. And I think something that has come across really clearly is that the diachroneity of this event is really meaningful. And I think what's going on here is that, or I think one hypothesis for what might be going on here is that there are probably several triggers for these ecosystem changes that probably can relate to one of any number of factors. It can relate to water loss, threatening the plants that tend to go extinct. There's a bit, or extinct or locally extirpated in some cases because they retreat and then come back. Some of the things that we tend to notice there is that there's a selectivity, that a lot of these plants tend to be what we would consider low water use efficiency plants. So they rely on abundant water in the environment, both for their reproduction in some cases, but mostly for their vegetative growth. So something happens in the local environment, whether that is local uplift, a change in meteorological or sort of medium to long-term climatic conditions, we lose a set of these plants. And then one of the things that's emerging from our kind of physiological understanding of these plants themselves is that they're also feeding back into the environment themselves. So when you remove these plants that are low water use efficiency, that are quite profligate with environmental water, that in turn changes the hydrologic regime for the local area that creates a positive feedback. So I think one hypothesis that might be proposed is that these differences are reflecting perhaps different causes that are being initiated at different times, but it's initiating the same kind of environmental plant community feedback that we see all over the world. And I think that is something that is what I'm taking away from the discussions that we've heard so far today, but I'd like to throw it out to other people if they have suggestions or ideas as well.
Comments, anybody? I mean, to me, in my simple-minded world, there must be an overall reason this happens everywhere, apparently. But then there's got to be reasons why it's not happening at the same time everywhere or in quite the same way. And so you're offering a an explanation of, I mean, there's sort of two levels of change here, right? Bill?
This what John says reminds me of why I've never thought very much of global diversity studies. If you want to really look at the distribution of anything globally, you have to find drivers that are doing something globally. And so the fact that you can agglomerate data, and especially when you look at where most global diversity studies get their data, you know, one time bin is China and South Africa, another time bin is Europe and South America, another time bin is North America and South America. So it's not even global. And then they draw these global diversity curves. And so what am I supposed to make of a global diversity curve? What does it mean? What factors drive global diversity? I'd be much more interested in seeing a series of regional diversity curves that I could see what they were doing so I could compare them to one another, kind of the way Sandra does statistics. If you gave her 10 diversity curves from 10 different areas, she could compare them to one another and tell us if there was something global going on. But yeah, but one giant curve, it's got what one of my colleagues calls a high coefficient of so whatishness. I just don't care about global diversity curves, and unless you can show me a global cause. And I think some of this question that John's pointing out is the same thing. I think that's a very interesting comment that we have a lot of hypersensitive plants. They evolved into their particular ways of life in the late Devonian. You can trace lycopsids back into wetlands in the early Devonian or even earlier. That lineage is in that particular ecosphere. And so these groups, the diversity is much lower. You know, if you go into a tropical rainforest today, you can find 300 species of trees in a hectare. John Knight and Stan could answer this better than me, but I don't think there are 300 species of trees in the entire Pennsylvania, let alone in 1 hectare. So that makes the dynamics of those forests very different. Like, and John Wilson, what you're talking about, you guys are just starting to look at the water relations of many of these plants, and that dictates a great deal of what happens to them. You know, we've not done that before. So I like that suggestion.
So, and I think I know what you think. I mean, the reason there's less species of trees is because it's really a lower diversity in the Pennsylvanian, or were there trees out there somewhere in Angara that we've just never discovered?
Oh, there's a lot of evidence, like several people have talked about here. There are things we haven't discovered. Again, I think of Hans Kerp and his group finding all these strange things in Jordan that are way early. That other people today talked about early occurrences of things. But even if you looked at lowland environments today, I mean, Herman's been in the Orinoco Delta. Maybe you could talk about its diversity, Herman, and maybe it's low when you get into swamps.
It is low, actually, in the Orinoco Delta. In the swampy area, the lowland area, the diversity is low.
Mm-hmm.
Okay.
And we're seeing a lot of that. We do have seasonally dry floras, though. We can see those, and they're not real diverse. It's just, and you mentioned mountain building. I know this is something you look back at your career when you get old and you realize this is all I did. You know, I said the same thing over 100 times. I haven't had a new idea in 30 years, but I still think we overemphasize this bit about elevation. You know, go for a walk, get in your car and drive up a mountain range, stay in the same climate zone. Elevation does not cause drought, period. You know, it's go to the tropics. There are peat swamps at 1,000 meters.
Right, but you know, Stan talked about, I don't know who's made this point, you know, and this flows into what Jonathan said. If you get a change in drainage, if you just get a change in slope, as you have the Variscan orogeny and then the Appalachian or Allegheny orogeny, why wouldn't that have a negative effect on these water sensitive plants? It's not creating a drought per se. It's just changing the hydrology of the surface and the shallow subsurface that plants can tap into.
If you go up the eastern slope of the Andes, you've got to go up until temperature changes the flora. Yeah, there's floral change, blah, 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 but you're still dealing with the same basic Andean species pool until you hit the point where it gets too cold. So it's rainfall and temperature And in fact, if you want to say mountain building, well, what is it about mountains? Plants don't care if they're mountains. They care about what the temperature of the rainfall is on the mountain, what the soil conditions are. They don't look around and say, geez, I'm at 1,000 meters elevation. I better get out of here.
Wait. But you said the soil conditions. I'm still trying to defend this idea that you would change at least the availability of surface and subsurface water simply having an orogeny. This
go to Lake Titicaca in South America. Look, that's one of the highest lakes. There's lakes, right? All you need to do is, I've said enough, but yeah, I'll get off here.
No. I mean, I mean, to me, and, again, I'm not a paleobotanist, so I'm coming at it saying, okay, we've got this big floral change. What's driving it? And why is it diachronous and complex as, because coming into this, to me, what I knew a few days ago is I knew Howard Falcon Lang. It's a Carboniferous rainforest collapse. Boom. It's like somebody turned the water off and all these things drop dead and we get a more xerophytic or mixed flora. It's far more complicated than that. But what we need to figure out if we're going to move forward is what might have been the real drivers of the change, both locally and at bigger scales, right? Or no change, as we apparently see in New Mexico from Sandra's analysis.
I think we have to consider the shape of the continents, which impact the ocean currents. And the ocean currents bring the rain. Extreme case is the monsoon, for instance, today. So the question is, did at that time the configuration of the continents change, and therefore the rainfall change over a large area of the continent?
Well, that ties in. I mean, if maximum coal in the Euro-American zone is basically what, Moscovian, Westphalian, something has to happen for the coal to stop accumulating, right? What stops the coal from accumulating? Why, when Martino shows us the Conemaugh, the Glenshaw, there's almost no coal, whereas below it there's lots of coal. What does that?
Oh,
rainfall.
Rainfall. Absolutely, rainfall.
Well, then that's
rainfall.
That's part of the story.
Yeah, but rainfall is influenced by where the ocean currents are, how strong the gyres are. For instance, the Panthalassa, the gyres were exceedingly strong because the ocean was so large, larger than any ocean today. So actually, what you had in New Mexico was probably a Mediterranean climate. Yeah?
So good point. So we need Sophia, I don't know if she's here, we need her to model, we need a model run where we put vegetation on Pangaea and we look at circulation patterns. It'd be interesting to see, has anybody ever modeled that? Tried to model not the vegetation itself.
For instance, I have not seen a map that shows the overall big vegetation types we have today on the configuration of continents in the Pennsylvanian, let's say, or a specific time in the Pennsylvanian. This should be done. I think in New Mexico, you had Mediterranean climate. You could have grown wine. You could have made wine.
We do now. The Spanish brought grapes here 500 years ago. We have a big wine industry. The climate is not Mediterranean anymore, I'm sorry to say.
Yeah.
Well, are we getting somewhere? Jorg has a comment here. You're muted, Jorg, I think. Jorg, you're mute.
Simply to add to the observations which Bill mentioned. Yesterday I have shown you the American flora, which is of Kasimovian, possibly earliest Geologic age. And if you look on this flora in gray beds in a fluvial dominated environment with some swamp intercalations. If you look on this flora, I have shown them Johannes Kirk, Weilchen dominated, Dichophyllum, Sphenobira, You will call it an Artunian flora, an early Permian flora, but it is Kasimovian.
All right. Well, listen, we've run over time for our discussion, and I know this group now. You throw microconchids or Cantabrian at this group, and we'll argue forever. So I would just say, I think we've had a wonderful day, really good talks. I want to thank everybody, and I want to thank both John Nelson and John Knight for their good cheer in presenting what is a fairly controversial topic. And having said that, we will continue tomorrow with the last session of the workshop, and there will be time again tomorrow to argue about the Cantabrian and other things. But I guess what I want to learn, I want to understand the biotic change that occurred as we went in the Kasimovian, not just on land and the sea, the timing. I mean, that's what we're all here for, and what drove it. And I think there's a lot of good ideas here, a lot of good observations, and we're making progress. So with that, we'll see you tomorrow, and the organizers will stay for a couple of minutes just to talk about logistics. Okay. Thank you all. Thank you for everything.
Thank you.